Oh my God.
Okay, here we go. Let's look at number 13. Okay. All right. I am going to make a guess. I'm looking at 13. I'm going to skim through the answers really quick, though. Sarah does not exist. Not defined from the left. What's my other option that doesn't exist? Okay. So let's take a look at this one. I'm not sure about this one algebraically off the top of my head. All right. Here's the thing that's the problem. Can I just substitute 3 in? No, it gives me a 0 in the denominator, plus it's giving me something about from the left. Okay. So one way that I could approach that is I could just start putting numbers in. If I don't know if I don't have access to my calculator, right, or graphing calculator, I could try putting some numbers in that are close to 3 from the left side. So I always go back here. Okay, so that's 3. Left of 3 is 2. So that would be like 2.5 and maybe 2.9. Remember when we did that? 2.99 is even closer. Okay. So let's see if we put some of those numbers in and see what's going on. And see if it gets just gigantic on us, maybe. So I'm going to use a table. Okay. So I'm going to go x, f of x. My first x I'm going to try is 2.5 because that might be fairly easy to calculate. So I have 2.5 over what's 3 minus 2.5? 0.5. Okay, what's 2.5 divided by 0.5?
4, 5.
Use a calculator.
5, 10, 15, 20.
How many times does 5 go into 25? All right, it should be somewhere around 5. 5 divided by 0.5. 5.
It's the first thing I said.
Okay, so that one's 5. All right, open up Desmos. Everybody open up Desmos. I'll let you do the calculation on the next one. All right, let's do 2.9. So I want you to put 2.9 into this thing, okay? And try it. Okay, everybody's putting in 2.9.
2.9 divided by 3 minus 2.9. 29.
All right, what did we get?
1.
What'd you get when you put it in?
29.
Do we agree with Junior? Did we get 29? Everybody good? Okay, now I want you to put in 2.99. Same calculation, do 2.99. What'd you get?
299.
Is it 299?
You know what Mr. Rama said? You have to look at the patterns. So the pattern is the more 9s, the bigger the 9.
Is that what we learned on Saturday, Junior?
If you put 2.999.
Was that the non-crazy guy?
No, that was the crazy guy.
Oh, the crazy guy? Okay. He was only a medium crazy. I didn't let you go to the one in the middle. He was really crazy.
You like Mr. Rama? Mr. Badass?
All right, let's go one more. 2.999. What'd you get?
2,990.
Okay, so what's this trending towards? No. These are giant numbers, you guys. It's going to infinity. Can we actually get a limited infinity? So this one really is what? Does not exist. Okay, so there were two different does not exist answers. Okay. Are we talking about something from the left and the right not being equal? No. So they'll look for the other does not exist answer. Okay. Function is not defined from the left. Probably that one because it's going to infinity. Oh, wait. There was a negative infinity. Is there an infinity answer? Oh, there is. I think it's positive infinity, not this one, because it is defined, right? So I would go with infinity. Let's get rid of does not exist. Okay. All right. So let's say infinity. So this has got to be, this one up here that's infinity is 14. Yeah. Yeah, let me see right now. All right. Look at the next one there. What do you think we're going to need to do? Can I just plug 0 in? I have a left and a right branch, right? So in order for the limit to exist, don't I need to do from the left and from the right? Okay, so let me, hold on. I think that's right, is it? No. Okay, let me set it up, and then I'll keep me a minute, okay? All right, so here's what I want you to do. I want you to find the limit as x approaches 0 from the left, and so of f of x, which means you're going to do this way, right? And then you're going to do the limit as x approaches 0 from the right of f of x, which means you're going to plug into that function. So everybody try those. Okay. Yes, he texted me during the lesson. I couldn't go pull you all out, so. Okay, do that problem right now. Shh. Do that problem. Annalise, go ahead, grab the pass, okay? Okay. What do we get when we put 0 into that top branch? 0. What do we get when we put 0 into the bottom branch? -3. Okay, so what happens on this one? Does the limit exist? The limit does not exist. Why?
Because from the right, it doesn't equal.
Yeah, it does not. It's the right and the left are not equal. So that has to be that last one that we saw on the other page. That's got to be 15. Okay.
Sine of 0 if you know your trigonometry.
All right. Am I able to just plug 0 into this one? No. What would BC students do on this one? Yep, let's L'Hopital. Okay. Derivative of the top, derivative of the bottom, right? Okay, so what's the derivative of sine? Cosine x, and the derivative of the bottom is 6x minus 1. All right, let's see what happens. I'm going to try plugging my 0 in. Let's see, what is the cosine of 0? 1. So I could go cosine of 0 and then say 1. All right, and then we have 6 times 0 minus 1. What's that end up being? Answer is -1. Okay. Where is that landing? Is that on there? First page. There it is. Okay, so we're going to start. What are we up to? 16. Okay, we'll start with 16 tomorrow. Okay. All right. Before we get into today's notes, okay, I need you to go to Google Classroom. Oh, maybe it's not. I don't know if I did the link to it the right way. Maybe. Go to Google Classroom. I put a link there. Okay? But I need everybody to do this right now.